Hello and welcome to this Skupper demonstration. We are going to see how to connect public and private clusters in a secure application layer. Let's start first providing some context with an example. A financial company could have an architecture similar to this one, a private data center to store customers' data for legal reasons, a couple of microservices and its database in a Google Cloud cluster, and the landing page in an AWS cluster. In this case, using a Skupper, we could save the setup of VPNs to interconnect the three different clusters. Let's talk about a different case. A developer working on a side project would like to test different clusters to see which one is going to fit their needs, without being familiar with the setup of VPNs. With the Skupper, they could get the interconnection of the different clusters in a fast and easy way. So, what is Skupper? Skupper is an application layer service in TechConnect. Enables communication across Kubernetes clusters, manages routers that communicate with each other using AMQP, and the connections between the Skupper routers are secured with mutual TLS. This allows hybrid cloud communication across different cloud providers, AWS, Google Cloud, or Azure. In this demonstration, we are going to work with three clusters, two of them publics and one of them private. The public clusters will have some common integrations with Twitter, PostgreSQL, and Telegram. The private cluster will have the database. Three different instances of Skupper will be running on each cluster. We are going to create the first link connecting the public 2 cluster with the public 1 cluster. This link will establish a bidirectional communication. Meanwhile, in the private cluster, we are going to create two links to connect it with the two public clusters. At this point, our virtual application network is configured. This allows the applications to behave like they are deployed in a unique cluster. Now let's talk about how all the pieces of this demo work together. The camel integration will search tweets that contain the word Skupper using the Twitter API. The result will be sent to a PostgreSQL sync camellet, which will insert the data in our private database. Meanwhile, another common integration will check the database for new values and will send them to a Telegram channel. As a result, our Telegram channel will see the new tweets that we have stored in the database. And now, let's start setting up the van. We are showing here the current services deployed on each cluster, Minikube running in local, Google Cloud, and IBM Cloud. The first thing that we are going to do is to install Skupper on each cluster by typing Skupper init. We want to make the database available in the van, so we will expose it by typing Skupper expose deployment Postgres. And now let's create the first token in the public 1 cluster. Token create. The last flag indicates that this token can be only used by 2 other clusters at most. Now let's create a link by typing Skupper link create. Now the public clusters are linked. We are going to create now another token to connect the public 2 cluster with the private one. Now we can link the private cluster with the public clusters. Seems like the van is configured. Let's check if the service of the Postgres database is available in the other 2 clusters. Yes, you can see here and here that the Postgres database is available. In the public 2 cluster, we are going to deploy the camel integration for Telegram. And in the public one, we are going to deploy the camel integration for Twitter and the PostgreSQL sync camelet. Just to check that everything works fine, we are going to check the database as well. Seems like we have already some results, but let's tweet about the Skupper. Okay, let's check the logs. Oh. We already have the result here in the Telegram channel, but let's check the logs. So we can see here, like the camel integration for Twitter has processed the tweet, and the PostgreSQL sync sent the data to the database. So if we check here the database, you can see that the last result is our tweet. And if we check the logs of the Telegram integration, we can see here the content of the tweet. So I hope this demonstration is useful, and thanks for watching.